No.
The central limit theorem is that when the sample size is large, the mean is normally distributed.
Yes.
Okay. So, number 2. What is the name of the important statistical result that states that when the sample size is large, the sample mean will be close to the population mean? And that's the law of large numbers.
That's large and law numbers, yeah. Okay. Okay, which of the following variables is or categorical? 1, the number of animals at the local zoo, a randomly selected brand of toothpaste at a convenience store, age in years of randomly selected vehicle and parking lot. Number 2.
Yes, that's what I got here. Okay, so I did not understand this one. The mean IQ test score in the United States is 100. 20 randomly selected statistics students took an IQ test, and the mean of their scores was 112. Which of these two numbers is a parameter and which is a statistic?
Okay, the statistic is the mean, and the parameter is the 20 randomly selected students. That's what I would say it is.
Okay.
Because this, do you get why the mean is the statistic?
Yeah.
Okay. That's what I would say.
Okay, that makes sense.
Okay. Number 5. Rotham City has 4 distinct neighborhoods. The property values are very similar within each neighborhood, but they vary considerably from neighborhood to neighborhood. One neighborhood has very low property values, and another has extremely high property values. Property taxes are usually roughly proportional to property values. What type of sample should we collect to gauge the residents' responses to a proposed increase in property taxes? I would say the stratified.
Oh, yeah, that's a good idea. So you would take some from each neighborhood?
Yeah, because the stratified, the definition at the top anyway is similar groups, which they're all neighborhoods that's similar, and then each group. So that's what I would do. I'd do stratified.
That makes sense. I was thinking either stratified or simple random, but stratified makes sense.
Okay.
When design experiments are conducted in public school systems, researchers typically choose a particular district and randomly select teachers of, say, 4th grade students in that district. The experiment is then conducted using all the students in the selected classes. Which type of sampling scheme is implemented? Cluster?
Yeah, I would say cluster. That's what I would say. Okay. At a school fundraiser, the name of every person who attended was entered into a drawing. At the end of the evening, 6 names were selected to receive door prizes. Which sampling scheme was implemented? That's simple random, right?
Mm-hmm.
Okay.
A special interest group is conducting a survey regarding wolves in Yellowstone National Park. To adequately gauge opinions on both sides of the political spectrum, the researchers took the list of registered Democrats and selected a simple random sample of 100 people. Then they took a list of registered Republicans and selected a simple random sample of 100 people. Which type of sampling scheme was implemented? Stratified?
Hold on, let me read. Would it be systematic?
According to the textbook, systematic is every case item in the population. And then stratified is dividing the data into similar groups and a simple random sample taken from each group. So they were divided into 2 groups and then they took a sample. That's what I was thinking.
Okay, yeah, I'll agree with that. Stratified. Okay.
I didn't do this one.
Okay, I have the thingy up. Calculate the descriptive statistics of the amount spent at the crossroad purchases. Give the mean, standard deviation, and 5 numbers summary. I didn't do this one either. I just brought this so we can do it together.
Because I printed it out and I did this on paper, so I didn't have the opportunity to use the internet.
Oh, okay. Okay, so
Are you doing it in SPS or in Excel?
I downloaded the Excel sheet.
I just don't know how to do anything in Excel. That's why I use SPS, because I learned that.
See, the confusing thing is, like, it's all divided between, like, cash and credit and iCards. So, like, do we take them all?
Yeah, I think so.
Okay.
I think we just need the, yeah, because it says the money that was spent.
Yeah.
So we need to use that.
Okay, because if I...
Okay.
What is going on over there?
Sorry, my husband's trying to find a pot so he can make dinner.
Okay. Yeah, I don't even know how to work Excel, so...
Yeah, I know how to do SPS, so I found it in SPS, but
Okay.
I'm not so sure about Excel.
Yeah, I'm not sure about Excel either because, like, it's 86 numbers.
I need to be able to find it. Do you know how to find it in one of them, though? Because you'll probably need that for the test.
What's the other one that he said?
Either SPS or Excel.
Okay, I'll probably figure it out with Excel and I'll just mess around with it. Oh, that was my problem. I think I figured it out. Okay. Maybe. Yeah, I'm gonna have to mess with this, so do you wanna mess with the SPF?
Yeah, I'm trying to remember how to figure out the quartiles. But I have the other one.
Okay, what's the mean?
Mean is 4.77.
And the standard deviation?
1.912.
We're gonna look this up really fast. And you didn't know how to find the quartiles?
Yeah.
Okay.
Hey, Aaron. Come here real quick. Walk me through. I need to find the first quartile. Do I do percentile?
No, you need to pull down.
Or the Q? Which one?
Just do, what's on the field? Just do equals. Typing Q.
Quartile. Cool. Oh. Quartile of. Yeah.
Oops. No.
I don't know. I don't know what.
So equals Q. And then double the quartile.
Okay, I just learned how to do this in SPS.
Okay.
I mean Excel.
Oh, okay. You're so lucky you have a husband to help you.
Yes, it's amazing. He's very helpful. He's taking the same class, just the engineering version.
Oh, okay.
And we have another problem.
Oh, you gotta do comma. Which quartile you want?
Oh,
So
comma,
no.
comma 1,
Inside the parentheses.
right here,
Yeah. So after the set.
comma 1.
Mm-hmm.
Okay. All right. So in Excel, what you do is at the bottom of the list of numbers,
Mm-hmm.
you do equals,
Equals
then you type the letter Q.
letter Q.
Yep. And a little menu should come up,
Oh,
and you double click on quartile.
The one without the dot.
The one without the dot, just quartile. It was the bottom one for me.
okay.
And then you highlight all of the numbers. And then after that, you, inside the parentheses that have all of the numbers, after the last number, you make a comma, and then it will come up with different quartiles, and you click which quartile you want.
Nice. What quartile is it asking for?
The first one. We have to do the first one and the third one. That's in the 5-number summary.
Okay, I got 3.42.
Okay, that's not what I got.
Oh gosh, heads up.
Which quartile are you in right now? Maybe you were in the wrong, one of us is in the wrong quartile?
I just did the 25% one.
Okay, that's
Can you screen share?
I don't know. Do you know how to screen share so we can see what you have?
Maybe.
It's the, on the side of this screen, it's the green button that has the arrow in the middle.
Okay.
You click on that and then it will come up with options. And then you click on the one you want me to see.
Okay.
Okay.
Do that?
Yeah.
Okay, that's what I did.
So she has the formula, right?
Did you type a 1 there? So I can't read what the last part is.
Yeah, we can't read what the last number
So after
is.
the comma?
So after the comma, what does it say?
I put Q to enter it, but then if I click 1, which is the 25th, I'll press enter and that's what will come up.
Okay, that's way off from what I have. That's not my answer. Okay, let me see.
Well, then watch what. Can you still see it?
Yeah.
Okay, so I did equals, and then I did Q, and then I clicked this quartile.
It's not showing up.
Oh no.
Try a capital Q. I don't know
What?
if it matters, but it might.
Or maybe
No.
Oh
it's
no.
a sec.
You
Are
can't.
you seeing options on your side?
Are there what?
Do you see options on your side of it?
Yeah, it says quartile.exe, quartile.inc, quotient, and then just regular quartile.
And just regular quartile is the one you want.
Okay, so I click that, and then I highlight every single one, right?
Uh-huh.
Okay.
You to be.
And that's mine says B2 to B86.
Yep, that's what I have.
Okay. And then I click 1, which says first quartile, 25th percentile.
Yeah, that's what I did too.
Okay, and then I'll do that, and I get 3.42.
That's what I got that time, so I must have been doing something wrong.
Okay. Okay, good. Well, not good, but like, you know,
No,
same page.
we're also going to need the third quartile.
Okay. So,
Oh, I know what I was doing wrong. Instead of clicking first quartile, I was clicking minimum value on accident.
oh, okay.
Wrong. So this is actually really nifty. I was just noticing that this one little formula thing is going to get you your whole 5-number summary. You're just going to have to click on them all separately. Because 5-number summary is minimum first quartile, medium third quartile, and maximum value. Cool.
What do we enter to find the min? The minimum?
Just do the same exact thing you were doing before.
Uh-huh.
Except when you usually click 1, it will be like 0 or something. There's an option there. It's 0.
Oh.
So just do what you were doing before, and then you'll have a 0.
Oh, mine is not working. Hold on. Oh, okay, hold on. I'm getting there. And then, okay, I got it. Okay, did you go 0.084?
I got 0.84.
That's what I meant.
Yeah.
That's what I meant. Can't read numbers, obviously. And I didn't even write it down. What was for the first quartile? 3.42.
4.2.
4.2. I didn't even write it down. Okay. Wow, that is really nice that it gives the 5-number summary by itself.
Yeah, I'm really excited about this, actually.
Me too. Okay, did you get 5.15 for the median?
Yep.
Okay. And then for the third quartile, 5.61.
No, we just want to do this. Uh-huh.
There's a quick way to get the whole time.
Oh, there's a quicker way to get the whole 5-number summary?
You're almost done.
Yeah, we're almost done with this stuff.
And did you get 10.45 for the max?
Yep.
All right.
And then we're supposed to create a histogram, which I don't know how to do in Excel, and my husband doesn't either, so
Okay.
I'm trying to remember how I did it in, I might have to go look this up. Because I used to know how to do this in SPS, because that's the next question. Okay, I was really good at it when we first did this, so I'm going to go find the textbook and look it up.
Okay. Yeah, I'm looking it up for Excel. I just don't know if it's gonna like.
Okay. Okay, so apparently there's a file that you open if you want to do it in Excel. That's what I found in the chapter.
A file? Oh no. Okay, I'm figuring out how to do it in Excel, but do you know how to do it in the SPF and just want to do it?
Yeah, I just found it. I just made one. I think I did it right.
Okay.
It
'Cause
looks. I don't know how he's gonna do that on the test. Make us like copy and paste it or something.
I have no idea.
Yeah, because the file that they tell you to use to make it in Excel doesn't open. Oh, here it's going to.
Oh, it doesn't?
No, it will now. It wants to now, I guess. I don't know.
Because I'm like, because you have to like add it in, so I'm adding it in, and then I'm gonna see what I can do.
Yeah, I just know that that this is gonna be on the preparation quiz thing today.
Yeah. Like the, yeah. See, like.
Okay. It's actually really easy in Excel. Using formula, it's not in Excel actually. You have to go to the textbook, and then there's a file for you to open, and then you click it and open it, and then you go to the histogram tab, and then you enter them in the left column, and then it makes the histogram.
Oh gosh. Okay. I just followed it, and it's like add-on, so now I have like histogram on Excel, so I don't know if that's the same thing or not. But it asks for input range, and I don't know what that is.
Okay, it didn't do that to me.
Oh, okay.
I'm using, I can open that up over here.
Okay, I'm gonna have to play with this because it's not working for me. So.
Okay. I just want you to know how to do it because we're going to have to do it for the group program quiz thing.
Oh, okay.
But I'm
Your
trying
screen.
to pull it up right now because I have it figured out. So, and now I'm on the right computer where I could actually like show you what I'm doing.
Oh, is mine still sharing the screen?
It is. Click somewhere else and it will go away.
Oh gosh, I'm sorry.
That's okay.
Click somewhere else.
That's what usually works for me. Or like click on yourself or something.
Oh no. Okay, hold on.
Okay.
That's not what I want. Okay, hold on. We're figuring this out. Maybe not. Well, can you see me now?
Yes.
Okay.
Okay. So here's how I did this. And I just went to the wrong chapter. I need to go to chapter 3.
Chapter 3.
Yep. Lesson 3, describing quantitative data. And then inside here, in this box, there's a file, quantitative descriptive statistics. And so then you click on that, and then it brings you to another page, and then you click on the first one, quantitative descriptive statistics, and then open. You can't see that dialog window, but and it asks me if I want to open it, and I say okay. And it's going to open with Windows Explorer, which is weird. And then I'm going to switch screen sharing. Share different screen. Oh, and it opens like this. And then I clicked on that, which it then opens in Excel. Then, once you get to Excel,
Then.
it's this little tab on the bottom that's histogram and descriptive stats, and then you paste your information in this blue box on the side, and then it will make a histogram.
Okay, hold on, let me... Ah, that's not what I want. Okay.
Ah! Somehow I now have it sharing you with yourself.
What?
I now have, like, it sharing my Google Hangouts. Okay, better. It was sharing a picture of you to you.
Oh, okay. Okay, hold on. What? Lesson 3, and then I click what?
Lesson 3, and then inside of lesson 3, you'll click on the Excel thing.
Oh, let me find it, because I don't see it. Oh, okay. Okay. Windows Explorer. Okay. And then I open that and I click histogram.
Mm-hmm.
Then what numbers do I put in the input range?
I didn't see an input range when I did it.
Okay, then let me show you.
Okay.
Okay. Okay, so after I opened the file, this is what comes up
Oh.
on mine. And if I do histogram and click OK, that thing comes up.
Oh, the input range, so it's looking, is it looking for the, like, what does it say? I can't read it very well.
It just says input range, and I have to put numbers in, and then it says bin range, and I have to put something in it. So I have to put, like, the quartiles, or...
Oh. Yeah, that's
and
not...
I don't know.
How did you get there? Can you show me how you got there?
Yeah, so... Okay, let's see. Do I have 2 Excel sheets open? Okay.
This one that you're showing me right now, that's the one you need.
Yeah, that one, right?
And at the bottom, it says histogram and descriptive stats. In the gray bar on the bottom of this page. Right there.
Okay.
Then in that box, you're gonna paste the numbers. The ones that we used a few minutes ago.
Okay. I go back to these and copy
You're gonna copy and paste.
like that.
And then you're gonna want to click up in A2 where it has a 1 and paste them up there.
Oh, okay. Just kidding. Actually, we'll undo all that.
Yeah. And then you have a histogram. Ta-da!
Wow, that is interesting. Okay, I am not closing that.
No.
Okay.
Keep that so you can just copy and paste it when it comes to time.
Yeah, exactly. Okay. Good.
Okay. Let's move on.
Please.
Jessica Meyer and her research team measured the body temperature of a sample of diving elephant seals. A thermistor was placed at a specific location on each seal to measure its body temperature. The body temperature of seals tends to decrease as they dive. The researchers estimated the typical body temperature of each seal at the time they initially dive and called this the representative temperature of the seal. Thermistors were placed in the heptical sinuses of 4 of the seals and named Bodil, Roberta, Larry, and Per. The seal's body temperature at the start of the dive was calculated to be these numbers. Complete the following table.
Okay. Oh, 14. Okay.
So what does your table look like?
What does my what look like?
Your table. What numbers do you have?
I have 37.91. 37 point. Wait, what table?
The one that you're supposed to create. Looks like that. The one that you had to add the numbers to.
Oh, I didn't do that.
Oh, okay.
So
So the first thing you had to do was figure out the mean, which I figured out to be 38.075.
Okay, hold on. A equals. Yeah, I don't even know what numbers to use to like minus because I only see the two numbers.
What? You only see two numbers?
Like, how do you? What is the value that goes in A? Like.
Oh, well, you do
91
minus the mean, which is 38.075. You had to figure that out.
How did you figure that out?
I added up 37.91 plus 37.25 plus 38.9 plus 38.16, and then divided by 4.
Duh. Wow. Okay. I'm looking at it and I'm like, what? Wow. Okay. Anyway.
Anyway, it's okay.
Okay. Wow. That was ridiculous. Okay. And B is, let me use my calculator. That's the one that you do. Hold on, I got this. Am I gonna do this right this time though? That's the thing. Okay, I'm not sure if my answer's right. I got 0.375.
For what?
For the B. Oh, for 12. So what's the value that goes in position with B?
I got 0.681. So one of us is wrong.
Okay, it's probably me. Okay.
So I was just filling out the whole table because that's probably going to be on the quiz. But
I'm not. Okay, so you did 38.75, right? Minus.
no.
Oh, just kidding.
I did 37.91 minus 38.075, and I got negative 0.165.
Okay. Why 0.075?
Because, well, it's 38.075 is what I figured out for the mean.
Oh, okay. I didn't put the O in. So 0.16, or then squared, right?
And then the next, well, that's what I got for A, for 11, negative 0.165. And then the next one, you just square that, yeah.
Wait, so the 0.681 you put for A, not B?
Well, no, 0.681 I put for B. Negative 0.165 I put for A.
Okay, let me do that again to make sure I have that. So point. I'm sorry.
That's okay.
Okay, that makes sense. Okay, we're good.
Okay.
Okay, what quantity is equal to the sum of the numbers in the squared deviation column? So yeah, to do all of them.
Yeah. Well, actually, you don't need to because it doesn't really ask. But I'm not exactly sure what it's asking there. Is that the mean, the standard deviation, or the variance? And I'm not really sure, so I'm going to go look that up.
Oh, I thought it was, okay, what quantity is equal to the sum of the numbers?
We are going to have to know what the standard deviation is, which we were figuring out. But I don't
Well,
remember what that is.
you said you did all of them.
Yeah.
What? Okay, when you add them up, what does it come to?
When I add up which one?
When you add up the squared deviations for Bodil, Roberta, Larry, and Per.
I get 20. Oh, I was typing that all wrong. Let's try that again. $1.534.
Okay, that. Ugh, I don't even know. Ugh. Okay, what quantity is equal to the sum of the numbers in the square deviation column? I almost want to say it's the variance, but I am not sure.
I'm in the chapter right now trying to figure it out.
Okay. Yeah, I think it's variance.
Okay. So just adding them up is none of those. Because the variance is those numbers divided by n minus 1. So it would be divided by 3 is what the variance is. And then the standard deviation is the square root of the variance.
So it would be none then?
Yeah.
Okay.
Because we have to do, and so then the answer I get is the square root of that. The answer that I get for this, what is the standard deviation of these temperatures, is 0.715.
That's the what you said?
The standard deviation, the answer for 14.
Oh, okay, I didn't know you moved on.
Oh, sorry.
No, you're good. I was like, wait, what? Okay. Okay. Okay, true or false? Under certain conditions, the standard deviation can be negative. That's true, isn't it?
I thought so.
I'm almost positive it is. Okay.
Google says no.
Yeah, so false. That's what I got too. Just kidding. Can never be negative. It can be 0.
Yeah.
But not negative.
In the same study, the researchers placed their temperature sensors in the three seals named Chick, Starburst, and Patty near their spinal cord and brain in the extradural vein. They placed thermistors in six other seals named Sir Richard, Jerry, Sammy, Kurt, Nunt, Jonesy, and Butler in their aorta, the largest artery in the body. Finally, they placed thermistors for other seals with names in the hepatic sinuses. The results from this study are summarized in the table below. Which location resulted in the most consistent temperature measurement for
Oh, no, you froze.
we're still live. Sorry, I didn't think this was going to take this long. We're only about halfway done. Okay. Apparently it was plugged in, but the charger is breaking. So.
Okay.
Okay, so we were on 16. Which location resulted in the most consistent temperature measurements from one seal to another? Justify your answer. And I said extradural because it has the smallest standard deviation.
I would agree.
Perfect.
Because the smaller the deviation, the closer they are together.
Mm-hmm. Yay.
Okay. In your own words and without using any mathematical symbols or statistical jargon, explain what the standard deviation is. Do not tell how to calculate the standard deviation, but explain what it represents. What? How are you so it explains how many spaces it is away from the mean.
Yeah, I said how spread apart the data is.
Oh,
That one's going to be different. Okay, the number of hours spent studying for an exam were recorded. The data are represented in the box plot below. Use this box plot to answer questions 18 and 19. 18. Give the 5-number summary of this data. I said 2, 4, 6, 8, and 12.
and I would agree with that.
Perfect.
That's what I said too. Alright, what percentage of the data lies between 4 hours and 8 hours? Like 50%?
Yeah. That's what I said too, because 4 is the 25th percentile and 8 is the 3rd quartile, so.
Alright.
Perfect, perfect. An observation from a normally distributed population is considered unusual if it is more than 2 standard deviations away from the mean. There are several contaminants that can harm a city's water supply. Nitrate concentrations above 10 parts per million are considered a health risk for infants less than 6 months of age. The city of Rexburg reports that the nitrate concentration in the city's drinking water supply is between 1.59 and 2.52 parts per million, and values outside of this range are unusual. We will assume that 1.59 parts per million is the value of mean minus 2 standard deviations, and mean plus 2 standard deviations is equal to 2.52 parts per million. It is reasonable to assume that the measured nitrate concentration is normally distributed. Use this information to answer questions 20 through 22.
Alright, estimate the mean of the measured nitrate concentration in Rexburg's drinking water. Okay. Hold on, I'm rereading it. I don't even know which numbers to use for the mean on that one.
Okay, what I did was 1.59 is 2 standard deviations, so I divided it by 2.
Okay.
What the standard deviation is, but I'm not exactly sure if that works. I don't think that works actually, because I get different numbers and they should be the same.
Wait, what do you mean? You get 2 different numbers?
Like when I do 2.52, that's different than 1.59, and I need to know. So my answer is wrong. So we need to figure out what's halfway between those 2 numbers, because it's 1.59 is 2 standard deviations one way, and 2.52 is 2 standard deviations the other way.
So you have to find out what's right in the middle.
So what if we discovered the range and then divided that by 4? Would that work?
Would the range be the 2.52 minus the 1.59?
Yeah, that's what I'm thinking. I'm not exactly sure if that would be right or not.
But when you minus that, it equals 0.93.
Yeah. So that's the range between the 2 numbers. So that's 2 standard deviations. So if we divided that by 4, would that work?
0.2325. That's too low to be a mean, don't you think?
Well, yeah, that's how many, that's the standard
Oh, the
deviation.
standard deviation, I knew that.
So it would be 2 of them.
That's times 2, which is 0.465. So,
I'm not sure if that's right or not, but I don't know how else to figure it out.
here, let me see. Oh, just kidding, hold on. 1 point.
No, that doesn't work. That's not right. I don't know how to figure this out.
I got the same answer for both.
You did?
So, like, I did the 1.59 minus 4.65, or 0.465, and I got 2.055, and then I did 2.52 minus 0.465, and I got 2.055.
Okay, so our mean is what? 2.055?
That's what I got.
Okay, and what's your standard deviation? 0.465?
Yeah.
Okay, that makes a lot more sense, actually.
Okay.
So between what two measured nitrate concentrations do approximately 68% of the data values lie?
Oh, can we use the little thingy on that one?
We don't need to. We could, but all it is it's to the mean minus 1 standard deviation and the mean plus 1 standard deviation.
Okay, I have to remember that.
Which we have a problem with that then.
What?
That means that 0.465 can't be our standard deviation because when we subtract that from the mean, we get 159, which we know is 2 standard deviations. So our standard deviation should be half of that.
Okay, so 0.465 divided by 2.
Hope we did right.
0.2325 is what I have then.
Okay.
Okay. So 68 is the 1. So that means we do 2.055 plus 0.2325.
Yeah.
Okay.
And then we
Minus it. Okay, 2.005. Yeah, I hope this is right too. Okay, I got 1.7725 and 2.2875. Is that what you got?
Yeah.
Okay, hopefully that's right. Okay. Okay, what is the mean and standard deviation of the standard normal distribution?
Isn't that like what we just figured out?
That's what I thought.
Was it 2.055 and 0.233?
Yeah.
The admission committee for most Masters of Business Administration programs requires the GMAT as part of the application for new students. It has been shown the scores on the GMAT are normally distributed with a mean of 542.3 and a standard deviation of 120.54. The minimum GMAT score required for admission to the MACC program in the School of Accounting at BYU is 500, but it's rare with students less than 600 to be admitted. Use this information to answer questions 24 through 32.
When we can use the applet, right?
Yeah, this one we'll want the applet for. So what is the probability that a randomly selected student will score above 542.3? And I said the answer is 0.5 because that's the mean. So half the data is going to be above it.
Point what?
0.5. Because 542.3 is the mean, so half the data is going to be above the mean.
Okay. What is the probability that a random selected student will score below 600? Okay, we have to find the z-score.
Mm-hmm.
And I always forget that. Okay, so it's the 600 minus the mean, right?
Yep.
Yeah. Divided by the standard deviation.
Yep.
I got 0.478 or point.
I don't need this computer anymore. This one if you need to do the homework.
No, I'm not doing that.
Okay. So I don't need to take up the entire living room. Okay, so what did you get for a z-score?
I got 0.479.
That's what I got too.
Okay. Okay, and it says above 0.316. That's what I got.
So the first question is, does a randomly student that will score below?
Oh, my bad. It's still the same.
I got, for scoring below 600,
Just
I
kidding.
got 0.684.
That's what I got too. I only had
And
the.
for off, I got your 0.316.
Okay.
I really hate these next ones. Find the GMAT score that corresponds to the 10th percentile.
Yeah,
Because we have to do algebra, and I don't like doing algebra.
I'm not good at those ones at all. Like, at all. Okay, so, yeah, I don't even know how to do these ones.
Okay, I know that we figure out the z-score by typing in the applet 0.10. And then the z-score that I got, if I'm doing this correctly, is negative 1.282. And then we have to plug that into the formula so that we're solving for x.
That is not what I got.
What did you get?
You put 0.10 into the z-score?
No, you put 1.10 into the area.
Oh, just kidding, that's why. Okay, 1.65 is a z-score.
Yeah.
And then what?
You think you can fix mine?
Yes.
Oh, that's cool. Okay. So then we have to do algebra and solve. So it's x minus 542.3. What? Yeah, I don't even know. Minus 542.3 divided by 120.54. And I am horrible at algebra. So look at that problem and I don't know what to do with it.
We have to solve for x?
Yeah.
And it's x minus the mean?
Yeah.
Okay, hold on. Okay, hold on. I think I got it. Okay, my answer is not coming up properly. So I'm not sure what to do. Mm. Hold on. Are you having any luck?
It just doesn't seem right, the answer that I'm getting. So I get like 6,000 and something, and I know that's not right.
Oh. My answer is coming back to the mean, and that doesn't make sense. Okay.
Oh, actually, I think I might have some idea. Maybe.
Okay.
Okay, actually that works. Okay. So when I make sure that it's negative, I get 344.012.
.12.
0.012.
.012. Sure. I have no idea how to do these. So then wouldn't it like be the opposite for the 90th percentile?
Oh yeah, but I feel like I'm getting a different z-score. I just tried it again, and the z-score I got was 1.282.
Oh no.
And the answer I get when I do the math for that one is 387.768.
Okay, I got a different z-score too on that one, so no worries.
Okay.
And how did you get the 386? What did you do?
I did the negative 1.282 times 120.54 plus 542.3.
Wait, where did you get the negative?
Because the z-score is negative.
Okay.
And so, yeah, you're right. For 90, we just do the same thing, but we have a positive z-score.
Yeah. And you did the z-score plus 120?
After I did the z-score multiplied by.
Okay. 120.54. And then divided by, or?
And then plus 542. So I did negative 1.282 multiplied by 120.54 to cross that out, and then I added 542 to it.
Okay. Wow, that is confusing. Okay. Are we ready to move on?
And then find the GMAT score that corresponds to the 90th percentile. So instead of having a negative, I had a positive, and the answer I got for that is 696.832.
0.932?
0.832.
0.832. Okay. Yeah, that is definitely not my strong suit. Okay, find the first quartile of the distribution of the GMT scores. No, I just want to look at like my histogram.
I just did it the same way I just did the last one, except I typed in 0.25. The applet. And then did the algebra. Which now that I've figured that out, that's a lot easier for me.
What?
The algebra, because I've just been staring at it and have no idea what to do with it lately. But now I know what to do with it. And so I'm like, yay, I can deal with this.
Isn't it amazing when that light bulb goes off?
Cool.
I know. Okay. So the first quartile. So we do the 1.15.
1.15. Where do you have 1.15?
That's the z-score I got when I put 0.25 in.
Oh. Are you making sure that only the lower is highlighted? Oh yeah, of course it would be. It wouldn't matter. But because that's not the z-score I get when I put 0.25 in. I get negative 0.674.
Okay, that's what I just got.
Okay.
Gosh, I have to pay attention to my highlighting because I always leave them both highlighted. Okay, so 0.674. And we do the negative on that too, right?
Yep, the first one is negative.
Okay. So then we do times the 120.54.
Yep.
Plus, right?
Yep.
And then plus the 542.3.
Yep.
Okay. And then that one's our answer, right?
Yeah.
Okay. Okay. Okay, I got that's a big number.
Did you make sure that you did the multiplication before the adding? Because I messed up on that one.
Do the multiplication before I add?
Yep.
$461 is what I got.
Yep, that's what I got too.
Okay, great. Okay, and then find the third quartile of the distribution of the GMT scores. So that we do that one above, right? So the only one highlighted is the highest one.
With the number that you have, it's the same number. It's just the positive rather than the negative. So you do the same formula except with positive 0.6, whatever it is.
Oh, okay. That makes sense. Okay. 0.6. I got 623.
Yep, me too. Cool. Consider a simple random sample of n equals 15 students taking the GMAT. What are the mean and standard deviation of the distribution of sample mean scores for all such samples? So the mean is going to be 542.3, and the standard deviation is 38.121. I figured that out by taking the standard deviation divided by the square root of 15.
Oh, man. Okay, hold on. Okay, what did you do?
I did the standard deviation, which was 120.54, divided by the square root of 15.
Oh, okay. Yeah, I remember that now. Okay. Ah. Oh no, my calculator just took on a mind of its own.
Oh no.
Okay. Cool. Okay, I got 466.8.
For what? For the standard deviation?
Oh. That's weird.
Yeah. So divided by the square root of 15 equals,
Oh, I times it. Hold on.
that's easy to do.
31.1.
Yeah.
Okay. And then the mean is just the one above, right?
Yep, the normal mean.
Okay.
Then what is the probability sample mean GMAT score for a simple random sample of 15 students will be greater than 600? So then we just do that normal formula thing, just using the new mean.
Wait, what's the new mean? I thought we had a new standard deviation.
I mean new standard deviation, you're right. That's what I meant, it's just not what I said.
I'm like, wait a second, what? So we find the z-score, right?
Yep.
Okay. Okay, I got 1.85.
Me too.
Yay. Okay, so I got 0.0322.
Me too. Perfect.
Yay.
Yay.
Good. Okay.
All we should have to do for the thing,
Oh, that's it.
yeah, and so all we should have to do for the quiz is re-answer those questions, those answers.
Sweet. For some reason I thought we had like 40 questions. I could have sworn when I went over this earlier I saw 40 questions. Okay, are you ready to try to do this thing?
Yeah, it should be really easy.
Hopefully.
Should just be copy and paste.
Okay. Yeah, and then input your answers.
Yeah.
Oh, that is weird. Hold on. Mine doesn't have a start button.
Doesn't?
That's weird. Okay, let me log back into that because that's weird. Yeah, it didn't have a start button. Does yours have a start button?
Yeah, mine has a start button.
Oh, that's weird. Okay, I got it. It wasn't
Okay.
there, and I'm like, what? Ugh. Okay, I'm starting. Okay.
Yeah, so it's just copying, I think.
Yeah.
Because it doesn't have, some of them is, it doesn't have all of them.
Okay.
Right.
Do you still want to read through them?
We can, to make sure we're on the same page.
Yeah. Okay, which of the following variables is or are categorical? The number of animals at a local zoo, brand of toothpaste, or age in years? Just the brand of toothpaste.
Yeah.
Okay.
The mean IQ test score in the United States is 100. 20 randomly selected statistics students took an IQ test, and the mean of their scores was 112. Which of the following statement is true?
I hate this one. Okay, 112 is the statistic. And 100. Oh, so that's not an option. So in our notes, I said that the sample was the parameter, but it's the whole total because 20 is not an option.
Which is weird to me.
It's weird to me too. So 100 is the parameter and 112 is the statistic.
Okay.
Sound good?
Yeah, that just sounds weird to me.
I know.
Okay.
Okay, moving on.
Rodham City has 4 distinct neighborhoods. The property values are very similar within each neighborhood, but they vary considerably from neighborhood to neighborhood. One neighborhood has very low property values, and another has extremely high property values. Property taxes are usually roughly proportionate to the property values. What type of status of samples should we collect to gauge residents' responses to a proposed increase in property taxes? Stratified? That's what you said, right?
Yep. Okay. When design experiments are conducted in a public school system, researchers typically choose a particular district and randomly select teachers of, say, 4th grade students in that district. The experiment is then conducted using all the students in a selected class. Which type of sampling is implemented? We said cluster.
Yep.
Okay.
At a school fundraiser, the name of every person who attended was entered into a drawing. At the end of the evening, 6 names were selected to receive door prizes. Which type of sampling scheme was implemented? We said sample random.
Yep. Okay. A special interest group is conducting a survey regarding wolves in Yellowstone National Park. Okay. On both sides of the political spectrum, the researchers took a list of Democrats and selected a random sample of 100. They took a list of Republicans and selected 100 people. What type of sampling was implemented? We said stratified.
Yep.
Okay.
A survey was taken of purchases to Crossroads. Open the data file Crossroads purchases and use this data to answer the questions 9 through 11. Using software calculates the mean of these data. We said
4.77. Oh.
1. 4.771.
Okay. I only did 2. Oops. Okay, using software calculate the standard deviation. 1.912.
Yep.
Okay.
I created a histogram. True or false?
Yeah, we did. A
Oh, yes.
lot of time trying to figure it out, too. Okay. Jessica Meir and her research team measured the body temperatures of a sample of diving elephant seals. Thermistor was placed at a specific location on each seal to measure its body temperature. The body temperature of seals tends to decrease as they dive. The researchers estimated the typical body temperature of each seal at the time they initiate a dive is called this representative temperature of the seal. They took this of the 4 seals, and the seals' body temperatures were recorded. Complete the following table and answer questions 12 through 15. What is the value of the number that goes in place A?
Negative 1.65.
Okay, making sure. I wrote like 3.
Wait. Negative 0.165.
Yeah.
Yeah. What is the value of the number that goes into the position marked with a B on the table? 0.681.
Okay. Okay, what quantity is equal to the sum of the numbers in the squared deviations column? We said none.
What is the standard deviation? We said 0.715.
Yep. Oh, I wasn't writing anything. 0.715. Okay, under certain conditions, the standard deviation can be negative. False.
We checked to Google. It said no.
Right? Believe the internet.
Okay, so they put some thermometers in different places in bodies, and this is the table. Which location resulted in the most consistent temperature measurements from one seal to another? And we said extradural.
Okay. I can define standard deviation in my own words. Sure.
The number of hours students spent studying for an exam were recorded. The data are represented by the blocks taught below. Use the chance to the next questions. What is the third quartile? That wasn't a question, but the answer is 8.
Well, that wasn't a question, but okay. What percentage of the data lies between 4 and 8 hours? Don't include a percentage sign. We said 50.
An observation from a normally distributed population is considered unusual if it's more than 2 standard deviations away from the mean. There are several contaminants that can harm a city's water supply. Nitrate concentrations above 10 parts per million are considered a health risk for infants less than 6 months of age. The city of Rexburg reports the nitrate concentration in the city's drinking water supply is between 1.52 and 2.52 parts per million, and values outside of this range are unusual. We will assume that these are the values of the mean minus and plus 2 standard deviations. It's reasonable to assume the measured nitrate concentration is normally distributed. Estimate the mean, and we said
2.055.
We worked really hard on that.
I hope it's right. Ugh. And then we said the standard deviation is 0.233.
Mm-hmm. And that they range. Or answers are actually an answer. Between what 2 measured nitrate concentrations do approximately 68% of the data values lie, 1.822 and 2.288.
And that's what we said?
Yep.
Yes. Okay, what is the mean of a standard normal distribution? Is that for the same one?
Mean of a standard normal deviation distribution? What is it asking there?
I don't know, because it doesn't apply.
Do we want to just type the same answer that we had before? Or?
Yeah, because I think it was, he didn't mean to say use 21 and 22.
Okay.
Okay,
And
so
then,
what did we have? We had 0.5.
We had, for mean, we had 2.055. And for standard deviation, we had 0.233.
But we already answered that.
I know. I don't really know what those questions want from us.
What is the standard deviation of a normal distribution? Was this one a normal one, though?
Yeah, it said we can assume it's normal.
Okay. Okay, hopefully those two are right. The admissions committee for most masters, okay, I'm not going to read that. They're the same numbers. No. What is the probability that a randomly selected student will score above that one? Oh, goodness. And we said, what did we say? We said
0.5.
On that one. Oh, my computer's going to die. Hold on, I'm trying to get my charger. Okay. We said 0.5.
And that one's just supposed to be the nearest tenth.
Yeah. Okay. What is the probability that a random selected student will score below 600? We said 0.479.
We did? No, that's the z-score. We said 0.684 is the probability.
Oh, kidding. I had that box. So 684.
What is the probability that a randomly selected student will score 600 or above? 0.316.
Okay, find the GM that scores with the 10th percentile. We said, what did we say?
387.7, but we're supposed to round to the nearest whole number.
So 387.
388, because it's 387.76.
Oh, okay. Okay, and find the G-score that rounds to the 90th percentile.
697 after rounding.
697.
Yep, after rounding. The first quartile of the distribution and 461.
Yep. Okay. The third quartile we said 624. Right?
Yeah.
Okay.
Consider a sample random sample of 15 students taking the GMAT. What is the mean of the distribution? We said, oh, it's supposed to be one decimal place. So 542.3.
And then what's the standard deviation for that? We said 31.12.
121. That one has to be 3 decimals.
121. Okay. What's
and
the?
Then
oh, sorry. What's
the probability
Sample scores. Okay, 15. And we said the 0.0322.
Right, but only 3 decimal places.
Yes.
Perfect. Let's see how we did.
Oh gosh, I'm so scared. I hate this part. Ah, yes.
You did really well. What did we get wrong?
We got the mean.
24 and 25.
I don't know what he wanted of that. Those are the
Me
only
neither.
ones.
I'm happy that we got the right though.
Ugh.
We did really well.
We did good. Ugh,
I feel a lot more confident for the test now.
I do too. And I am so happy we can use like 1 page of notes. Because I'm writing formulas down.
Me too.
All that.
And definitions. Okay, so Thursday is weird for me because I'm busy till 8. So, but I'm available. I don't know what your like afternoon looks like, but I'm available from 3 to 4:45.
Okay, I can do that because I don't have school during the day and I have a soccer game Thursday night, so I can't do Thursday night.
Right. So would like 3:10 work? I should be home by work.
Thursday at 3:10. Okay, yeah, that'll work fine.
Perfect. I'm glad
Okay.
that worked out. Perfect.
Okay. I'll see you then, okay?
See you then.
Okay,
Bye.
bye.